Hey there everybody, welcome. We are going to look at some of the problems in 6.02 and 6.03. Instead of going ahead and teaching ideas and then practicing, we're just going to go through problems and make sense of them as we go. So first one is, it says to find the general solution of this. So find the antiderivative of xy. So the problem would have been written as dy dx equals xy, and to go back and find the solution for it. So first thing you have to deal with is dy dx, you need to split up. So you've got dy equals xy dx. Now you need to get all of your x's with the dx, and you need to have all of your y's with the dy. So I'm going to divide both sides by y. So we have dy over y equals x dx. Now, I should be able to recognize at this point from chapter 5 dealing with logarithms that the antiderivative of dy over y is natural log absolute value of y. Okay, that's idea 1. Idea 2. Antiderivative of x is x squared over 2, so times 1/2 plus c. Now, to get my particular solution, I need to exponentiate, meaning I'm going to turn these into a power. And so we're going to, these are now the power of e. Now, that was supposed to be an n over here. Sorry, guys. And so e to the natural log of y is absolute value of y. Now on the right side, I've got e to the 1/2 x squared plus c. Now we don't write it like that. We actually would just say, next up, I can ditch the absolute value, because if I raise e to a power, it's going to be positive. So I can just say y now. So y equals e to the 1/2 x squared times e to the c. Because when you add powers, when you have a base and you are adding the powers, that meant that you multiplied the bases. So I have e to the 1/2 x squared times e to the c. Well, instead of writing it as e to the c, I'm just going to write it as c. So it's c times e to the 1/2 x squared. And then if they gave you an initial condition, you could then plug that in. But this is one of the more common questions I get from the section of, what is going on? Why am I multiplying by c? I thought I always added when I did the antiderivative. And you are correct. You are adding c, but when you exponentiate it and it becomes a power, when you are adding c in a power, it's the same thing as multiplying times the base to that c. So does that help? Oh, and then the other one people don't like, no insults, forgive me, but people don't like it. E to the c is just a number, and so I just write it as c. Because c is an unknown and it's representing all constants, and so it's okay to leave it like that. All right, let's do another one. I have a smattering of problems here, so we can kind of play with them. So 5 is the more approachable one, so we're going to start with that. dy dx equals 5x over y. First thing you got to do is you got to get your y's to one side and your x's to the other. So I have y dy equals 5x dx. Take the antiderivative. I get y squared over 2 equals 5x squared over 2 plus c. Now I can multiply everything by 2, so I get y squared equals 5x squared plus 2c, but it's c, so you just leave it as c. You could leave it that way, or you could write it as y equals plus or minus the square root of 5x squared plus c. Both are fine. This is pretty nice though. Let's do a different color for our next one. Let's do let's just do one of these guys. So number 3 here. So as I look at number 3, I've got dy equals y plus 2 dx. I need to get my y's on one side, so I have dy over y plus 2 equals dx. If I take the antiderivative of that, I mean, it's 1 dx over here. I think that would be a good place to start. But as I take the antiderivative of this, I get natural log of y plus 2 equals x plus c. Exponentiate. Okay, and I now have y plus 2 equals e to the x plus c. Plus c is up as a power. Okay, so I'm going to rewrite this as y plus 2 equals e to the x times e to the c. So I have y plus 2 equals c e to the x. Let's do one of these fun ones. I mean, I think it's fair to say they're getting more and more difficult as they get deeper. So let's 10. Let's do it. We're diving right in, folks. So I've got xy plus dy dx equals 100x. There's going to be a lot of layers to this problem. So first thing I need to do is I need to get dy dx by itself, so I can multiply both sides. So I have 100x minus x times y. So that's step one. Step two, I'm going to get my dx to the other side. Okay. You notice that I'm nowhere close yet, right? Because I have an issue. I've got this x times y and I have this x. What is in common for both of those is x. So I can say dy equals x times 100 minus y dx. Now I can divide and get things on one side. Take the antiderivative, I get negative natural log of 100 minus y equals 1/2 x squared plus c. Natural log of 100 minus y equals, let's just get this negative sign over here now, plus c. And so if I exponentiate, I now have 100 minus y equals c times e to the negative 1/2 x squared. I hope you're okay with the fact that I took one little shortcut on that one. But the other way that you would see this is, since that's a negative power, is sometimes you'd see it as this, is c divided by e to the 1/2 x squared. You can see it both ways. Hope that helps a little bit to kind of start with one of the simpler problems. Number 9 up here is an odd, so go to Calc Chat. That'd be a great one to solve. That's a very tough one. Okay, so 7 is your more basic that you need to know. You need to be able to just pound through those and just work through those. 6 is like not even a full star. It's like a half a star. Okay, where this is good. Number 7, number 10, much more difficult. You notice that number 10 and number 9 are the more difficult ones. So here we go. Let's do one more. Let's not do it off of that though. This is a good problem. So we're going to do 23, and so the rate of change of v. Got it. What is that? Rate of change of v is dv dt. It's proportional to v. In other words, it's directly proportional to v. That's just notation that means it's proportional. Now, if it's proportional, we're going to have a constant involved. So let's just, k, let's do k. Okay. When t equals 0, so at t equals 0, v equals that. So v of 0 equals 20,000. V of 4 equals 12,500. And then it's asking what is v of 6. Okay, this is a nice problem. It kind of breaks a lot down. So if dv dt equals that, that means dv equals kv dt. Okay, so if I take the antiderivative, assuming I have to move it over, so I have dv over v equals k dt. So if I take the antiderivative, I get natural log of v equals kt plus c. So v equals e to the kt plus c. And by simplifying, I get v of t, just so I can write it in my function notation, equals c e to the k t. Now, I need to use my initial conditions. I always start with the one with the 0 because it's going to cancel stuff out and it's going to make life much easier. So I'm going to start with V of 0, which equals 20,000, equals C e to the k t. So 20,000 equals C e to the 0. Anything to the 0 is 1. So I now have my initial condition. So I can now rewrite my function as 20,000 e to the kt. So I've used my first condition. I now use my second condition. V of 4 equals 20,000 e to the k t. And that equals 12,500. I now have a harder problem because I now have e to the 4k equals 12,500 over 20,000, right? 125 over 200, so I have e to the 4k equals, let me simplify, so I have 5 out, so I get 25 over 40, which is 5/8, okay? So I've got e to the 4k equals 5/8. How do I solve for k? Take the log of both sides. And so I now have 4k equals natural log of 5/8. So k equals 1/4 natural log of 5/8. I now have my v of t. And then I just plug in 6. Okay, it's just algebra from there. So I'm going to pick up the next problems on the next screencast, but I think that's good for now. Thanks for tuning in. Have a good one, guys.